Remember to bring a torchlight for tomorrow's camp, Turbo Girl.
Oh yes, I've got it here with me. But it's not as bright as it used to be. I wonder why.
Well, let's find out. Are these batteries new, Turbo Girl?
No, teacher. They are used ones.
This could be one of the factors which affect the brightness of the bulb. The current flowing through the circuit has decreased.
You mean the amount of current flowing through an electric circuit will affect the brightness of the bulb?
That's right. Can you think of any factor which will affect the amount of current flowing through a circuit?
I know, the number of dry cells. If you use more dry cells in a circuit, the amount of current flowing through the circuit will increase.
Well done! The greater the number of dry cells used, the greater the amount of current and the brighter the bulb will be.
Teacher, take a look at these two circuits. Why is it that the bulb in circuit X is brighter than the bulbs in circuit Y?
What is the difference between circuit X and circuit Y, Turbo Girl?
Circuit Y has one more bulb than circuit X. The number of bulbs used also affects the amount of current?
Yes, when more bulbs are used, the brightness of each bulb in the circuit decreases. Look at these three electric circuits. What do you observe?
All three circuits consist of the same number of dry cells and light bulb. However, the arrangements of the dry cells are different.
Very observant. The dry cells in both circuits A and B are arranged in series, but the dry cells in circuit C are arranged parallel to one another. Now, let us see what happens when all the switches are turned on.
Bulb A is the brightest among the three bulbs. So, the arrangement of the dry cells in the circuit affects the brightness of the bulbs too.
Exactly. An electric circuit is a system and is made up of different parts or components. Like any other system, all parts or components are very important and they affect one another. The electric circuit will be affected if any component is faulty or removed. What are you doing, Turbo Girl?
I am trying to make this circuit work.
You are connecting the circuits with ribbons?
That's because I cannot find any wires.
Turbo Girl, only certain materials allow electricity to pass through. They are known as conductors of electricity. You are now using an electrical insulator. This type of material does not allow electricity to flow through.
Teacher, how can we find out whether a material is a conductor of electricity?
We can use a circuit tester to find out. A simple circuit tester can be set up using some batteries, a pair of wires, and a light bulb.
We will close the circuit using the material to be tested.
Yes, when the bulb lights up, we can conclude that the material is a conductor of electricity.
If the bulb does not light up, then the material must be a non-conductor of electricity.
That's right. This is an electrical wire. It is actually copper wire wrapped with rubber. Do you know the reason, Turbo Girl?
Rubber is a non-conductor of electricity. It allows us to touch the wire even though electricity is flowing through.
Absolutely.
Ouch! They are so hot.
What happened, Turbo Girl?
I forgot to bring in my stationery this morning, And now, all of them feel so hot except the eraser. Why is this so?
Purple Girl, compare the materials of the stationery. What do you notice?
The metal ruler, coins, and keys are made up of materials that are electrical conductors. They felt hot when I picked them up. As for the eraser, it is not so hot. Its material is not a good electrical conductor.
You are very sharp. Good conductors of electricity are generally good conductors of heat too.
I see. So I can conclude that rubber is a non-conductor of electricity. It is not a good conductor of heat.
That's right. Today, we have learned something about the electrical system.
Each component in an electrical circuit affects one another. The number of dry cells affects the brightness of the bulb. The number of bulbs affects the brightness of each bulb. The arrangement of the dry cells in the circuit affects the brightness of the bulbs too.
Yes, and we have looked at electrical conductors and electrical insulators.
Electrical conductors are materials that allow electricity to flow through them. Materials that do not allow electricity to flow through them are called non-conductors of electricity or electrical insulators.
Right. We also concluded that good conductors of electricity are generally good conductors of heat too.
I have enjoyed today's lesson very much. See you in the next lesson, teacher.